Hello, algebra students. Mr. Laurence here. Pardon me, clearing my throat. And we're continuing our exploration of equation solving, going real deep with it, trying to make sure we're getting really good at this stuff. Now, in some of my classes on Monday, I talked about this, but in other classes I didn't get a chance to, so it's going to be in the video. The questions that I use when I solve an equation. Well, the first question I use, what is my goal? Okay, well, my goal is to get the variable alone. Okay, and I have a sample problem over here, and this semicolon y just means we're solving for the y. You know what sometimes I like to do? I like to circle the y. Yeah, I like to circle the thing I'm solving for. So in this case, it's to get the y alone. All right, well, let me go to question number 2. What numbers are attached to that variable? Well, it looks to me like I have a -2. There's a -2. And then I also have a 5x. And a 5x. Remember, I think about 5x as one number because I'm thinking about y as my variable. Okay? All right. My next question I ask myself, how are they attached? Well, the -2 is attached by multiplication. It's a -2y, which means -2 times y, right? By multiplication. All right, and let me see here. What was it? The 5x. The 5x is going to be attached by addition, I believe. Why do I say addition? Because it's a positive 5x, isn't it? So the 5x is attached by addition. By addition. All right. So, 2 more questions here. Which operations undo those operations? Well, multiplication is undone by division, and then addition is undone by subtraction, right? And so these are all going through my head as I do this. I don't write them down unless I really need to, but I just go through and do them. All right, which should I undo first? Well, this is where listening to Saddam comes in, or perhaps sad me, if we had an exponent involved. Okay, now, Saddam's not a rule. You can undo multiplication or division first, but I've warned many of you, like Tuesday, JoJo was doing that, and she's doing very well. But you have to remember that if you're multiplying or dividing both sides of an equation, you might be involving distribution. You got to be careful with that. Everything needs to get divided. So let me come up here to this problem. This positive 5x minus 2y equals 13, solving for y. And let me clean it up a little bit, and I'll show my work. Now, I know I've got to get rid of the 5x and the -2y. If I want to divide by 2 first, I don't. But if I want to divide by -2 first, I can't just do it here and here. I have to distribute it. And I would rather not deal with this number and this number if I don't have to. Now, I may have to later in the problem, but for right now, I'm not going to. If it had looked like this, 8x minus 2y equals 14, well then dividing by -2 wouldn't be such a bad thing because they're all even, okay? So you wanna have more than one trick in your bag, so to speak. You wanna be able to do problems with different approaches. All right, so I'm gonna do this one the way I've been demonstrating it. I know the 5x is attached by addition. I know the -2 is attached by multiplication. So Saddam tells me to get rid of the 5x first. So I'm going to subtract 5x. And by the way, you should have heard Holly Krieger today in class. She said that. She did a great job, something very similar. All right. What the heck just happened there? Hold on a second. All right. Let's try that again. Calligraphic pen. There we go. Draw the line. Okay. So these will cancel, leaving me a -2y. And on the right-hand side, I'm going to have a -5x plus 13. Now, some of you want to write 13 minus 5x, and that is perfectly acceptable. It is correct. I know there's a type of graphing we're going to do later on where it's going to be easier. if the variable is first, okay? If it doesn't mess you up and you're going to do fine, then, well, I don't mind you doing it that way. That's a good way to do it. All right, now, I got to get rid of this -2, so I'm going to divide by -2. Do not divide by y. If I divide by y here, I have to divide by here. I have to divide here. The problem gets more complicated. I want to get the y alone. You know, one thing I said is I like to circle that y sometimes. All right, I'm not going to divide by the y. I want the y to stay put. So, I'm going to divide by -2. Going to divide by -2. Remember, you have to distribute. Some of you want to do this, -5x plus 13, and divide by -2. And that's okay, but then you have to simplify it. I'd rather just do it in one step. Okay, so let's see what we get here. The -2's will cancel, leaving me with just a y. A negative divided by a negative is a positive. I'm not going to go mixed number here. I'm going to leave it as an improper fraction, 5/2x. And then this, you can go mixed number if you want, or you can leave it as improper fraction. Again, I'm cheating a little bit. I know something that you don't, where it's going to be easier as a mixed number. But with the x term, I like to go improper fraction. Okay? But if you gave me this, you would get full credit. If you gave me this, you would get full credit. If you gave me this, you would get full credit. I don't like this. This is probably my least favorite. Yuck. I wouldn't do that way, but it's not wrong. It's not wrong. It's just that I know something that we're going to be doing later on, and doing it this way will be very difficult, but it is not wrong. Okay, so y is alone. And there is one of my possible solutions. All right, let's try these two. I want you to pause the video and go ahead and see what you can do with them. All right? If you're watching at this point, I'm assuming you've already tried. If you haven't tried, please try. All right, here comes my solution. I'm going to solve for y in each case. Oh, I didn't tell you that. I'm sorry. I'm so sorry. How can I tell you to do it? Anyway, all right. So we're going to solve for y. I like to circle my variable sometimes. What's my goal? To get the y alone in this case. What numbers are attached to y? I got a 3 attached by multiplication, a -8x attached by subtraction, okay, or an 8x attached by subtraction. Which am I going to undo first? Well, Saddam's going to tell me get rid of the -8x. So I'm going to add 8x to both sides. Mr. Merrick, paging Mr. Merrick. Dr. Kevin Merrick. Do I get 27x here, Kevin? What's that? No, you're absolutely correct, Kevin. You can't because they are unlike terms, so you won't put them together. All right, let me see here. Emma Caton. Emma, what should I do now? Yes, that's right, Emma. I'm going to divide by 3, but I'm going to be careful, right? Because I'm going to divide all 3 numbers by 3 because I have to distribute on the right-hand side. So I'm going to be left with a y. 8/3 x. I don't want to go mixed number there. If you went 2 2/3 x, you're okay, but I don't like to. I will go mixed number on the one without the variable, and that's going to be what? 6 1/3, I believe. And there you go. That is my solution. Okay. By the way, 6.3 is not acceptable because this is 1/3 is not 0.3 or 3/10. 6 1/3. If you had 6 and the 3 repeated, I would say great. Okay. All right. Same thing over here. It wouldn't be 2.3 or 2 3/10. It would be 2.3 repeating. Okay. Let's come on over to letter B here, solving for y again. All right, I'm going to subtract 6x from both sides. All right, and we're going to cancel. I'm going to get a -2/3 y equal to a -6x plus a 15. Okay, now some of you are going to multiply by 3 next. And that's not a bad thing to do, but I'm going to do it in one shot because then you're going to have to divide by 2. I'm just going to multiply by 3/2, and I'll make it negative. And then I'm going to distribute over here and multiply by a -3/2. If you want that, 6/1. And then I'm going to multiply by a 3 over 2, and I'll put that 15 over 1. And I think I'm going to rewrite this so it looks nice and pretty. I feel pretty, oh so pretty. All right, there we go. Okay, and then I'll have a negative 6x over 1 times a negative 3 over 2. And then 15 over 1 times a negative 3 over 2. All right, so the 3's are going to cancel. The negatives are going to cancel. The 2's are going to cancel. I'm left with y. Okay, here the negatives will cancel. 2 will go into 6 3 times. 3 times 3 is 9. 9 times x, 9x. All right, here they're not going to cancel, are they? So I'm going to multiply. I'm going to get a negative. 3 times 15 is 45. Divided by 2. That's an acceptable answer. I think I'm going to turn it into a mixed number, though. It's not the one with the variable. I know that 44 divided by 2 is 22. And 46 divided by 2 would be 23. So then 45 divided by 2 would have to be 22.5. So y could equal 9x minus 22.5. All right, that's the answer I want to go with. Of course, this is okay. All right, one last one I want you to try, and then we will be done. All right, let's go with dx minus qb, and let's make that equal to pw, and we're going to solve this for lowercase b. All right, so I circle the thing I'm solving for. And my first step is to ask myself what my goal is. Well, it's to get the b alone in this case, right? What numbers are attached to b? Well, I have a dx, right? And I have a q. Okay, the dx is attached by addition, all right? And the q by, oh, it's a negative q, isn't it? By multiplication. Saddam's going to tell me to get rid of the dx first, so I'm going to subtract dx from both sides. And when I do that, I'm going to get a negative qb, which is going to be pw minus dx. And then I'm going to divide by this negative q. But I'm going to be careful to do it in all 3 places. So the left-hand side will simply become b. This could become a negative pw divided by a q. Those will cancel, leaving me with a dx over q. And there you go. All right, that's it for this video. Mr. Lawrence signing off. Have a good night, everybody. Where's my mouse? I can't find